All right, here's solutions to problem 44 off the GRE subject math practice test. This problem, I'm sure there's some mathematical way, there's some formula, there's got to be some way to evaluate this limit right here. I don't know it. But you can still answer this question even without knowing it by sort of thinking about what all this information means. And I don't know whether the test takers wanted you to kind of use intuition to guide you through this problem or to use some formula, some method that I'm unaware of. Maybe somebody in the comments will post some other way to do this. But one way you could solve this, think about what's going on here. So here's my graph. And what I want to know is what is the height of this curve when the x-coordinate goes towards negative infinity. So when I get way the hell out to the left on my graph right here. And what do I know? Well, I know that when the x-coordinate is 0, the y-coordinate is negative 1. So it goes through this point right here. And then I also know that y prime plus xy equals, wait, how am I going to make any sense of that? Well, what you can do is solve this equation for y prime. So I got x minus xy, which you could rewrite as x times 1 minus y. So what this is saying is the slope of this line is just a product of the x-coordinate and 1 minus the y-coordinate. So what that ends up telling you, if you think about what this slope will be, I can figure out the initial slope, no problem, when x equals 0, y equals negative 1, and so 0 times 1 minus negative 1 is 0 times 2, which is 0. What I'm saying is this thing starts out flat right here. But then what happens? Well, you can consider what happens when it goes to the right if you feel like it, but that's not relevant because the problem is asking you what's the limit as x approaches negative infinity. So really, I just want to know what happens when x goes to the left. When x goes to the left here, so just imagine a little bit. Now x is a small negative number, and y is fairly close to negative 1. It might have changed slightly, but I moved so little that I didn't give y much chance to change. And since the initial slope was 0, it couldn't move too much. So this is close to negative 1. So I'm taking some small negative number and I'm multiplying it by 1 minus negative 1, roughly. So some positive number. So I get a negative number. So what that's telling me is this thing starts to go up a little bit as I go this direction. And the further I go to the left, the more negative this number becomes. But then think of what happens on this other. There's kind of opposing forces here. This becomes a more negative number. Negative 1, negative 2, negative 3, negative 4. But 1 minus y. Well, y is going to get closer and closer and closer to 1. And it's getting closer and closer and closer to 1 because it has a negative slope here. This x-coordinate always being negative, and 1 minus y will always be positive because y will never be able to be more than 1. Because the minute that y hits 1 up here, or as y approaches 1, I guess is a better way to say that, this term approaches 0. So I have some number times some number that approaches 0. This levels back out. The slope gets back to 0. So what I'm saying is that if I were to draw this very roughly speaking, my graph would look something like this. I'd have this asymptotic behavior at 1, and then a tangent line here at negative 1, and it wants to know what's the limit as x approaches negative infinity. Well, that answer has got to be positive 1. I know it cannot be positive infinity because the curve here can never get past a y-coordinate of 1 because the minute the y-coordinate gets to 1, or as it approaches 1, this term approaches 0, and 0 times anything else will be 0. So the slope will get back down to 0, and I would need this slope to be a negative number to kind of get past that value. I guess is one way you could say it. The answer also can't be negative infinity because my slope starts, or my graph goes through negative 1 right here. And then anytime I am to the left of this point, anytime I have a negative x value, I'm taking a negative number and multiplying it by a positive number. So this slope is always negative right here. And so if the slope is always negative, then the height of this curve always has to be greater than negative 1. So it can't stay at negative 1. It can't get all the way down to negative infinity. My only possibilities are 0 and 1. Could it have stopped at 0 somehow? Well, in theory, yes, it could have. Think about what's going on with the slope right here. I'm taking a product of two things. when the y coordinate is 0. I don't know what the x coordinate is, but if the y coordinate is 0, 1 minus 0 is just 1. So if I have an x coordinate like -5 or something, and I'm not implying that -5, 0 is on this graph, but for a minute think about if it were. If -5, 0 were on this graph, then that would tell me that the slope should be -5 at that point. So this thing should be going up rather quickly if you read it from right to left. So it would get past 0 really quickly. There's no reason it would stop at 0. It won't stop until it gets to 1, 1 being the number that'll make this term equal to 0. So the answer to this question would just be equal to 1. So I guess I'll end this here.